Right now, as you sit here listening, the universe may have already spoken, not in light, not in anything your eyes could ever see, but in a brief, invisible pulse that crossed billions of years only to arrive and vanish in less time than it takes you to blink. No warning, no pattern you could notice, just a spike in the silence. And the unsettling part is this: by the time we detect one of these signals, the event that created it is already ancient history. Whatever happened is long over. These signals are called fast radio bursts, and at first glance, they sound almost insignificant. Just radio waves, just noise, buried deep in the background of the cosmos. But that impression doesn't last long, because each one of these bursts carries an amount of energy so immense that for a fraction of a second, it can outshine entire galaxies in the radio spectrum. Not over hours, not over days, in milliseconds. It is difficult to hold that idea in your mind, something so brief, yet so powerful that it compresses an unimaginable release of energy into a moment so small you would miss it entirely if you weren't already watching. And that is exactly what makes them so disturbing. The universe, as we tend to imagine it, moves slowly. Stars are born over millions of years. Galaxies evolve over billions. Even the most violent cosmic events, supernovae, black hole mergers, they unfold on timescales we can follow, measure, and understand. There is a rhythm to it, a sense that, given enough time, everything reveals itself. But fast radio bursts break that rhythm completely. They do not unfold, they erupt, a single sharp pulse rising out of nothing, crossing the entire observable universe, and then disappearing without leaving a clear trace of what caused it. Imagine listening to a vast, empty room. No echoes, no movement, just silence, stretching in every direction. And then, for the briefest possible instant, you hear a sound so loud, so concentrated, that it should not be possible for it to come from nowhere. That is what these bursts feel like to astronomers. For most of history, we had no idea they existed. The universe appeared quiet in this way, predictable, continuous, but that was only because we weren't listening closely enough. Now, with more sensitive instruments, we are beginning to hear them again and again and again. Short signals scattered across the sky, coming from distances so vast that their journey began before Earth even existed in its current form. And yet, despite detecting dozens, then hundreds, now thousands of them, we still don't fully understand what creates them. Some repeat, most do not. Some come from distant galaxies, others from places that challenge what we thought we knew about where such energy could exist. Each one is a message without a clear sender, and every time we detect one, we are left with the same quiet question hanging in the dark. What in the universe can produce something like this and do it in an instant? If this is the kind of content you want more of, subscribing to The Cosmic Depth takes 2 seconds, and we post new documentaries every few days. Because the deeper you look into fast radio bursts, the more they begin to feel less like random events and more like cracks in our understanding of how the universe really works. They are not just signals. They are interruptions, moments where something, somewhere, breaks the silence of the cosmos with impossible precision, then disappears before we can fully comprehend it. And the truth is, we may already be surrounded by them, happening constantly, flickering across the universe like distant lightning, most of them forever unnoticed. Only now are we starting to listen closely enough to realize the universe is not as quiet as we thought. For something so powerful, so impossible to ignore once you understand it. Fast radio bursts were not discovered with excitement. They were dismissed. Not because they were weak, not because they were subtle, but because they seemed wrong. The first time one was seen, it didn't feel like a breakthrough. It felt like a mistake. In 2007, a graduate student was searching through old telescope data, not looking for anything unusual, just analyzing signals, filtering noise, doing the quiet, patient work that most discoveries are built on. And then, there it was, a single, sharp pulse, lasting only milliseconds, but far too strong, far too structured to be random interference. At first, it didn't make sense. Signals like that aren't supposed to exist. Radio telescopes are constantly picking up noise from Earth, from satellites, from distant cosmic sources blending together into a quiet background hum. Most of what they detect is filtered out, ignored, categorized as interference. Because most of it is. So when this signal appeared, the simplest explanation was the obvious one. It had to be local. Maybe a glitch in the instrument. Maybe a stray signal from Earth. Maybe something as mundane as a passing aircraft or a piece of electronics misbehaving. Anything except something real. But there was a problem. The signal carried a very specific signature. As radio waves travel through space, they pass through clouds of gas and plasma. Thin, invisible material scattered between stars and galaxies. And as they pass through it, something subtle happens. The different frequencies of the signal begin to spread out. Lower frequencies arrive slightly later than higher ones. It's a kind of delay, stretched over time, a fingerprint of distance. And this signal had that fingerprint, not just a little, but to an extreme degree, far beyond anything that could be explained by something inside our galaxy. If the signal was real, it hadn't come from nearby. It had come from deep space. That realization changed everything because suddenly what looked like a glitch became something far more unsettling. If this signal had traveled across millions or even billions of light years, then whatever created it must have been unimaginably powerful. And yet, it lasted less than a second. For a while, the scientific community remained cautious. One signal is not enough. Extraordinary claims require extraordinary evidence. And so, the discovery sat in a strange place, not fully accepted, not fully rejected, a curiosity, an anomaly, something that might eventually be explained away. But then, it happened again. Another signal. From a different part of the sky with the same strange properties, and then another. Slowly, carefully. A pattern began to emerge. These were not isolated errors, not random glitches. They were real, short bursts of radio energy arriving from distant parts of the universe, each one carrying the same telltale signature of having traveled through vast cosmic distances. The term fast radio burst was born out of that realization, a name that sounds simple, almost understated, for something that challenges the limits of what we thought was possible. But even then, even as more detections came in, there was a lingering doubt. Because some signals, especially rare, unexplained ones, have a way of misleading us. And then came a moment that nearly unraveled everything. Astronomers began detecting bursts that looked similar, but came from much closer to home. They traced them back, not to distant galaxies, but to something far more ordinary. A microwave in a laboratory when the door was opened too early. For a brief moment, it seemed like the entire mystery might collapse into something almost embarrassing. Had we misunderstood everything? Were these signals nothing more than human-made interference, misinterpreted as cosmic phenomena? The doubt returned, stronger than before. But the story didn't end there, because as researchers dug deeper, they began to separate the false signals from the real ones. The local interference had a different structure, a different pattern, a different signature. And the true fast radio bursts, the ones from deep space, remained unexplained, unmistakable, and impossible to ignore. What began as a suspected error had quietly transformed into one of the most profound mysteries in astronomy, not because we didn't see it clearly, but because once we did, we had no idea how to explain what we were seeing. And that is when the question truly began to take shape. Not just, what are these signals, but something deeper. What kind of universe allows something like this to happen over and over again in silence, without warning, and without an obvious source? It is one thing to detect something unusual. It is something else entirely to realize just how powerful it truly is. At first, fast radio bursts seemed mysterious because they were brief, because they appeared and disappeared without explanation. But the deeper you look, the more unsettling detail begins to emerge. Each burst, despite lasting only milliseconds, carries an enormous amount of energy. Not large in the way we casually describe things, not a lot by everyday standards, but large in a way that strains the limits of imagination. To understand this, you have to step away from human scales entirely. Think about the sun. Every second, it releases an immense amount of energy, enough to power all life on Earth, enough to light up an entire solar system. And it does this continuously, second after second, year after year. Now imagine taking all of that energy, everything the sun produces over the course of several days, and compressing it, not into an hour, not into a minute, but into a fraction of a second. That is the scale of a typical fast radio burst, a release so concentrated that for a brief instant, it rivals the total energy output of billions of stars combined in radio wavelengths. And then it's gone. No lingering glow, no expanding cloud of debris we can easily track, just a spike in the data. This is where intuition begins to fail. Because when something releases that much energy, we expect to see consequences. A supernova leaves behind a remnant. A black hole merger sends ripples through space-time. Gamma ray bursts flood space with radiation we can trace across the sky. There is a story we can follow. But fast radio bursts don't give us that story. They give us a single sentence, and then they erase the rest of the page. And yet, hidden inside that brief signal is evidence of something even more extraordinary. As the burst travels across the universe, it interacts with everything in its path. Thin gas between galaxies, charged particles drifting in the void, invisible structures that stretch across cosmic distances. Each interaction leaves a mark, a slight delay, a subtle distortion, a fingerprint of everything the signal has passed through. By the time it reaches us, the burst is no longer just a signal, it is a record, a compressed history of its journey across the universe. And when scientists decode that record, they find something astonishing. Many of these bursts have traveled billions of light years. They began their journey long before Earth looked the way it does now, before human history, before many of the stars in our night sky had even fully formed. Which means the energy we detect, the brief spike that appears and disappears in an instant, is the final moment of a journey that has lasted longer than civilizations, longer than species, longer than most structures we can imagine. And still, it arrives as a sharp, clean signal, not faded beyond recognition, not lost in noise, but clear enough that we can detect it across the entire observable universe. This raises a quiet, unsettling question. What kind of event can produce something so powerful that even after traveling billions of light years, it remains detectable as a single, distinct pulse? Because the universe is not empty. It is filled with obstacles, fields, particles, radiation. Signals weaken over distance. They scatter, they fade into the background. That is what should happen. But fast radio bursts refuse to fade the way we expect. They arrive, still strong enough to stand out against the noise of the cosmos, which means that at their source, they must be even more powerful than we imagine. Powerful enough to survive the longest journey possible and still be noticed. And yet, we do not see the event itself, only the echo. This is what makes them so difficult to understand. We are not observing the cause. We are observing the aftermath, compressed into a signal so brief that it barely gives us time to react. It is like hearing a single crack of thunder without ever seeing the lightning. You know something immense has happened, but you are left to reconstruct it from a sound that lasted less than a second. And the more precisely we measure these bursts, the more they begin to challenge our assumptions. Because they are not all identical. Some are brighter, some are more distant, some show signs of passing through extreme environments, dense magnetic fields, turbulent regions of space. Each one adds another piece to the puzzle, but none of them, on their own, are enough to explain the whole picture. And so, we are left with a strange contradiction. We know these events are real. We know they are incredibly powerful. We know they come from across the universe. And yet, we still do not know what creates them. It is as if the universe is showing us the result, but keeping the mechanism hidden, letting us measure the energy, trace the journey, analyze the signal, but never quite see the source. And in that gap between what we can observe and what we can explain is where the mystery deepens. Because whatever is producing fast radio bursts is not just energetic, it is precise, it is efficient, and it is happening far more often than we ever expected. Once you accept the scale of these bursts, once you understand just how much energy is being released, the question becomes unavoidable. What could possibly create something like this? Not in theory, not as a mathematical possibility, but in the real universe. Over and over again, in different places, across billions of light years. At first, the ideas were wide open, because when something doesn't fit into existing models, the mind moves quickly, sometimes too quickly, toward the unknown, exotic objects, colliding black holes, even the distant, quiet suggestion of artificial signals. But science moves carefully. Speculation is easy. Evidence is not. And over time, one possibility began to rise above the rest, not because it was simple, but because it was just strange enough and just powerful enough to begin matching what we observe. Magnetars, a type of neutron star so extreme that even among the most violent objects in the universe, they stand apart. To understand a magnetar, you first have to understand what remains after a star dies. When a massive star collapses under its own gravity, it can compress its entire mass into something only a few kilometers wide. A neutron star, dense beyond intuition. A single teaspoon of its material would weigh more than a mountain. But a magnetar takes that already extreme object and pushes it further. Its defining feature is its magnetic field. Not just strong, but incomprehensibly strong. Trillions of times more powerful than anything we can produce on Earth. A field so intense that it can distort atoms, bend the structure of matter itself, affect space in ways that are difficult to visualize, and within that extreme environment, energy builds, slowly, relentlessly. The crust of the neutron star, rigid but under constant stress, begins to crack, not gently, but violently. Starquakes, fractures in a surface that is already pushed to its limits. And when that happens, something extraordinary is released. A sudden reconfiguration of the magnetic field, a violent snap, like tension breaking in a system stretched too far. And in that moment, a burst of energy is unleashed. For a long time, this idea remained theoretical. It made sense on paper. It explained the scale, the speed, the intensity. But there was still a missing piece. Proof. Because until we could connect a fast radio burst to an actual magnetar, the theory remained just that. And then, something changed. In 2020, for the first time, A fast radio burst was detected from within our own galaxy, not billions of light years away, but close in cosmic terms, close enough that we could trace it back to a known object, a magnetar. The signal was weaker than the distant ones we usually detect, but its structure was unmistakable. It matched the same pattern, the same brief, intense pulse, and for the first time, the connection was no longer theoretical. It was real. A magnetar had produced a fast radio burst. Quietly, this shifted the entire field because it meant that at least some of these mysterious signals had a source we could begin to understand, but only some. And that is where the certainty begins to fade again. Because not all fast radio bursts behave the same way. Some are far more powerful than what we observed from that nearby magnetar. Some occur in environments that don't seem to match the conditions we expect, and some repeat again and again from the same location, which complicates everything. Because if magnetars are responsible, then not all magnetars behave the same way, or there is more than one kind of source. Other ideas still remain. Collisions between dense objects, black holes interacting with their surroundings, even more exotic possibilities, involving physics we do not yet fully understand. Each theory explains part of the picture, but none of them explain all of it. And so we are left in a familiar place. We have a leading explanation, a model that fits much of the evidence, but not perfectly. And in science, that imperfection matters, because the universe has a way of revealing itself, not through what fits, but through what doesn't. Magnetars may be the answer, or they may be only part of it, a piece of a larger mechanism, one that we are only just beginning to glimpse. And as more fast radio bursts are detected from more distant places, under more varied conditions, the question does not disappear. It sharpens. What are we really looking at? A single phenomenon expressed in different ways? Or multiple processes producing signals that only appear similar from a distance? Because if the latter is true, then fast radio bursts are not one mystery. They are many, and we are only just beginning to separate them. For a while, there was a quiet assumption that whatever was causing fast radio bursts, it was a one-time event, a single catastrophic release of energy, something that happens once and then never again. It made sense. After all, the energy involved is immense. The scale is extreme. It felt natural to imagine something destructive, a collision, a collapse, an ending. But then, the universe did something unexpected. It repeated itself. In 2016, astronomers noticed something that should not have been possible: a fast radio burst coming from the exact same location more than once. Not just twice, but again and again and again. At first, it was met with hesitation, because repetition changes everything. A one-time burst can come from something that destroys itself in the process, a star collapsing, two objects merging, but a repeating signal means the source survives. It continues. Whatever is producing the burst remains intact and active, and that creates a very different kind of mystery. Because now we are no longer looking for a single, violent ending. We are looking for a system, something stable enough to produce immense bursts of energy without destroying itself. That realization narrowed the possibilities, but it also made the problem more complex, because sustaining that kind of energy output over multiple events requires conditions that are difficult to maintain. And yet, the signals continued. Some repeating bursts follow patterns, not perfectly regular, but not entirely random either. Clusters of activity, followed by silence, as if something is turning on and off or shifting between states we don't fully understand. Others are more chaotic. No clear rhythm, no predictable timing, just sudden pulses emerging from the same point in space with no obvious warning. This variation is important because it suggests that even among repeating bursts, there is more than one behavior, more than one underlying process. And when scientists began to trace these repeating signals back to their origins, another layer of the mystery revealed itself. Some of them come from galaxies that are very different from our own. Smaller, more active, filled with intense regions of star formation, environments where extreme objects, like magnetars, are more likely to exist. But not all of them. Some repeating bursts come from places that seem quieter, more stable, not the kind of environment you would expect to produce such violent, energetic events. And yet, they do, again and again. This forces a difficult question. Are all repeating fast radio bursts created by the same type of object behaving in different ways? Or are we seeing entirely different systems, producing signals that only appear similar when they reach us? Because from our perspective, everything is compressed into a single kind of observation, a pulse, milliseconds long, arriving from deep space. But that simplicity may be misleading. It may be hiding a much more complex reality, different causes, different environments, different mechanisms, all producing signals that look almost identical by the time they reach Earth. And then there is something even more subtle. Some repeating bursts show a kind of structure within the signal itself. Tiny variations, subpulses, patterns that unfold within that fraction of a second, as if the burst is not a single event, but a sequence compressed into an instant. This has led to an even deeper line of thinking, that what we are observing is not just the release of energy, but the behavior of an extreme system, operating under conditions we don't yet fully understand. Something rotating, something shifting, something interacting with its surroundings in a dynamic way. And each burst is a glimpse into that process, but only a glimpse, never the full picture. Because no matter how many times it repeats, each signal is still over almost as soon as it begins. And so, we are left trying to reconstruct a complex, ongoing system from fragments, each one lasting less than a heartbeat. It is like trying to understand a machine by hearing only the briefest clicks scattered over long periods of silence. You know it is there. You know it is active. But its true nature remains just out of reach. And yet, these repeating bursts may be the most valuable clues we have, because unlike the one-time events, they give us multiple chances to observe, to measure, to compare. They allow us to listen again and again to something that refuses to fully reveal itself. And with each repetition, the mystery doesn't fade, it deepens, because the more we learn, the clearer it becomes. That fast radio bursts are not a single, simple phenomenon. They are a language, one we are only just beginning to hear, and not yet able to understand. There is a quiet shift that happens when a mystery stops being just a mystery. At first, fast radio bursts were exactly that. Unexplained signals, strange flashes in the data, questions without answers. But over time, something changed. They began to reveal not just themselves, but the space between everything else. Because every fast radio burst carries a history, not of its source alone, but of everything it has passed through. Between galaxies, there is matter, not in the way we usually imagine, not stars, not planets, but thin, almost invisible gas, scattered particles, a faint structure that stretches across the universe like a web. For a long time, much of this matter was missing, not physically gone, but hidden. Our models told us it should exist. Our observations couldn't fully account for it. It was there, somewhere, but difficult to detect. Until fast radio bursts gave us a way to see it. As these signals travel through space, they slow down slightly, not in the sense of losing speed, but in how their different frequencies arrive. Lower frequencies lag behind higher ones. The more material the signal passes through, the greater this delay becomes. And that delay can be measured with precision, which means each fast radio burst becomes a kind of probe, a way of mapping the otherwise invisible matter between galaxies, not by seeing it directly, but by observing its effect on something else. It is a subtle method, but powerful, because instead of looking at the universe, we are listening to how it interferes with the signal passing through it. And from that interference, we can begin to reconstruct what lies in the dark. This has led to something remarkable. Using fast radio bursts, scientists have started to locate the missing matter in the universe, the vast reservoirs of gas spread thinly across intergalactic space that had remained hidden for decades. In a way, these bursts are illuminating the darkness without ever producing light. They are revealing structure without being part of it. And that changes how we see them. They are no longer just random events. They are tools, signals that allow us to measure distances, trace cosmic structures, and understand the large-scale composition of the universe. But even that may not be their full significance, because the more precisely we study these bursts, the more they begin to test the very fabric of our understanding. Their signals pass through magnetic fields, through plasma, through regions shaped by gravity on the largest scales, and each of these leaves a subtle imprint, a twist in polarization, a distortion in timing, a signature that can reveal conditions we cannot reproduce or directly observe. In this way, fast. Radio bursts are not just messages, they are experiments already in progress, carried out across billions of light years using conditions far more extreme than anything on Earth. And we are simply listening to the results. This is where the mystery becomes something deeper. Because even if we eventually understand what creates these bursts, even if we identify every source, classify every type, and map every variation, they will still remain something extraordinary, a natural phenomenon that allows us to probe the invisible universe, to measure what cannot be seen, to trace what cannot be touched, and to ask questions that would otherwise remain out of reach. But there is one more layer to this, a quieter, more unsettling thought. These signals are everywhere, happening across the universe constantly. Most of them will never be detected. They will pass through space, through galaxies, through emptiness, unnoticed. And yet, each one carries information. Each one tells a story. Each one is a moment where something extreme has occurred, far beyond our reach. And for a brief instant, the universe allows that moment to be heard. Then it disappears again, leaving behind only a trace and a question. How much of reality exists just beyond the edge of what we are able to detect? How many signals, how many events, how many structures are unfolding right now in silence? Fast radio bursts do not just challenge our understanding of astrophysics, they challenge something deeper, the assumption that what we can observe is a complete picture of what exists, because clearly it is not. We are listening through a narrow window, catching fragments, moments, echoes of events that have already passed, and from those fragments, we are trying to reconstruct an entire universe, a universe that is far more active, far more complex, and far more mysterious than it first appears. And perhaps that is the most important realization of all. Not just that fast radio bursts exist, but that they are reminders that the universe is not silent. It is speaking constantly in signals we are only just beginning to hear. And if this changed the way you see fast radio bursts, the cosmic depth has more waiting for you. Subscribe, and I will see you in the next one.